So we have 10 and 11 to finish. We did the graph for 10, we did the table for 10, but we haven't finished the table, not the table, the questions. So this is the app, Desmos. It's desmos.com/scientific. If you use the website, it's the same. Or if you use the app, it kind of looks like Delta Math, the Delta Math keyboard. I use the website just because when I'm teaching, it's easy to Zoom. I can't Zoom on the app, but on my phone, I have the app. This is, like I said, this calculator, especially when you're doing math, when you're just doing basic adding, subtracting, I need to add these two numbers. I need to subtract these two numbers. Then your phone calculator is fine. But when you're doing some math for class, it's not the best, especially when you're doing exponents, because it does all that stuff, but your phone wasn't made to be a calculator. It's made to be a phone. They just said, oh, people would like a calculator app on there, so let's throw one. They haven't updated the calculator app in 15 years. So they're not the best, the ones on Android and the ones on iPhone. So this is the one I use when I'm using my phone as a calculator. Okay, so last thing we did was we graphed this guy, and now growth. Growth or decay. This one's decay, right? The bottom here. The bottom is going to be y equals 0, the x-axis. It crosses the x-axis, or crosses the y-axis at 0, 4. Right? The domain is always, for these graphs, for these exponential curves, it's always negative infinity to positive infinity. The range goes bottom to top. Well, the bottom we said was 0. We said the bottom is 0 here because that's the bottom of the graph. And then the top is going to go up forever and ever and ever. So we say positive infinity. Okay, so number 11, I want you to tweak number 11 a little bit. Change number 11 a little bit to have this. The power is different, and you don't have that minus at the end, minus or plus at the end. So change it a little bit, because this is going to match more of what they're going to ask you to do on the worksheet, on the practice worksheet. Okay. Okay. So when we plug in for x, first thing I have to do is add 2, right? Because we do exponents first. It's not going to have any parentheses, so I'm going to add 2. When I add 2, then I do exponents. Okay, so let's set this up. So I'm going to plug it in. I'm going to say 1/2 times 4 is the base. And then the first one is -2, and then +2, right? The next one is 1/2 times 4, and then the exponent is -1 +2. Okay, so all of these guys are going to look very similar, except for the power, which I plugged in for x. So before we put it into the calculator, we have to do exponents. So the first guy in the table, what exponent am I going to get for this guy here? What exponent am I going to get? Am I going to plug in when I use the calculator? Not -2. What is it now? 0, right? They cancel each other out. 0. So it's going to be 4 to the 0 power. So now I'm going to go to my calculator, and I'm going to put that exact guy. I'm going to say 1 divided by 2 times 4. And then we said what power was it going to be? 0 power. Okay. So now our answer is 0.5. And if you push the button to the right, the fraction button, it changes it to a fraction too. So you can write it down as a fraction. You can write it down as a decimal. It's up to you. Okay. So that guy is 1/2, 0.5. Okay. The next guy, the power is not going to be 0. Now, when I do that, -1 plus 2, the power is going to be +1. So I'm going to go back to my calculator. That's the nice thing about Desmos is you can go right to, you don't have to change anything else except this guy here. So now when I plug in a 1 power, it makes 2 as an answer. Okay, so I have my first dot. My second dot. Now let's go to my third dot. So first thing I got to do is exponents. So when I add the exponents, I get +2. Oops. So I go over here and I'm going to change the power to +2. So now it's 8. The answer is 8. Where's my next dot? The next power, -1 plus 2, +1. Let's see, what did I do? I put the wrong number in. Yeah, it should be +1, right? So I'm plugging in +1, so it should be +3. So when I plug in +3 for the power, starts to get really big, right? 32. And then when I plug in 2, it becomes a bigger power. Now the power is going to be +4, right? +4. So if I change it to +4, it's going to get even bigger, 128. Now when I go graph, that's going to be a problem because I need 5 dots. I need 5 points. These last guys aren't going to be able to be graphed. One, I can't go right 1 up 132. I can't go right 2 up 128. It's not going to fit my graph, right? So a couple things I want you to do. When were the numbers like these guys right here? These guys are on my graph, right? The guys I highlighted, they're going to be on my graph. What was the difference between these guys and these guys down here? Why were these guys down here off my graph? What caused them to be too high? What caused these guys to be too high? Yeah, so X is positive. And when I plugged in a positive number, what happened? What happened when I plugged in a positive number? What happened to the power? What's the power doing? From here to here, what's power's getting bigger, right? Every time I go down, the power is getting bigger. The power is the one that's making the number big. So what I need to do is plug in some numbers here. Instead of these guys, I'm going to plug in a couple more numbers to make my 5 dots. What type of numbers can I plug in to make the powers not as big? I already plugged in -2, -1, 0. I don't want to plug in 3, 4, 5. I don't want to plug in those because that'll make the powers way too big. But what numbers could I plug in here instead that wouldn't make the powers as big? What's a number I could plug in? Can't go 3. 3 would make the power even bigger. 3 would make the power 5. That's 4 to the 5th power is in the hundreds. Can't plug in 4, 5. So what number should I plug in? What numbers, instead of 1 and 2, what numbers should I plug in? How about -3? The negatives seem to work, right? Let's try -3. So when I plug in -3 plus 2, let's see what happens. -3 plus 2, -1. -1's not a big number. So let's go to our calculator and see what happens when I plug in -1 for a power. It's a small number, but it's still on my graph, 0.125. So 0.125. Okay, that number would be on my graph, left and then up. Let's try the pattern. Let's see -4. What happens if I put a -4 in? The power becomes -2. Again, it's a small number, but it's still on my graph. Small numbers are on my graph. Big numbers, huge numbers aren't on my graph. So 0.031, 0.031. Okay, so those are the ones I'm going to graph on the graph. I can't graph 132 and 128 because they're too big. They're not going to fit on my graph, but I need 5 dots. So let's start at the top. -2 up a half. So -2 up not even a whole. Not even a whole. So it's going to be a half unit. -1 up 2. Left 1 up 2. 0, 8. Don't go left or right at all. I just go up 8. 4, 5, 6, 7, 8. So there's my 3 original. And then I'm going to put the 2 guys that I had. So -3 up barely anything. -4 up barely anything. It's going up, but barely, like a fraction, like pennies, going up pennies. Okay. All right. So now growth, is that growth or is that decay? It's growth. Where's the bottom? Where would my bottom be? 0, good. It'd be up here at 0. Where does it cross the y-axis? 0, 8. What is the domain? What's the domain always going to be for exponential curves? -infinity to +infinity. The range goes from the bottom to the top. The bottom is the blue line, right? 0. This arrow, where is it going to stop going up? Never. Okay. One thing I want you to notice. Which one has an asymptote that's not 0? There's only one that has an asymptote, a bottom, that's not 0. Which one is that? Number 9, right? What's different about this guy than the others that is causing that guy to be -2? Well, close. Do you see a -2 in the problem? Right there, right? It's got a -2. Number 10, does it have a minus or a plus at the end? Nope, 0. This guy, did it have a minus or a plus at the end? Nope, 0. Same thing here. There's no minus or plus. That's what it's 0. So whatever this guy is out here, that's what your bottom's going to be. Okay. Alrighty. Okay, so let's go to your practice. I gave you 8 problems of practice. Not much, but enough practice so that you can get used to doing this on your own. So for each problem, you have to do 4 things. First thing, I need 5 points. Need the table filled, and I need 5 points. Second thing, draw it. Draw the graph. Connect the dots. It's going to look like one of those guys on the board, right? It's going to look like one of those guys. Next thing, what is the domain, or sorry, what is the asymptote? The asymptote is the bottom. Where is the bottom? And then the domain and range. Those are the 4 things. Okay. I will do one of these with you guys. So look at them. Look at all 6 of them. There's 6 of them. Look at all 6. Which one do you want me to do? Take a look at it. Which one do you want me to do? I'll do one of them with you, and then I'll let you do the other 5. So which one would you like me to do?
What's HA?
Say what?
What's HA?
Asymptote. Right, a horizontal asymptote, yeah. Also known as bottom, right? It's the bottom of the graph. So which one would you like me to do? I'm going to pick number 1. So if you want me to do number 1, great. But if you want me to do a different problem, tell me. So I'll do it. 1, 2, 3, 4, 5, or 6.
4.
Yes.
Do number 6.
6, sure. Number 6. Let's take a look at it. Number 6. Okay. So the first thing I'm going to do with number 6 is I'm going to plug in points. Okay. Let's use the ones that I used for most of the problems the last time. Okay. If some of them are too big or too small, then I'll have to use other points. But if they all fit, then I won't have to. Okay. So I'm going to, now next thing I'm going to do is I'm going to plug in 5 times parenthesis 1/2 -2 plus 2. Okay. 5 times 1/2 -1 plus 2. 5 times 1/2 0 to the 0 power plus 2. 5 times 1/2 to the first power plus 2. 5 times 1/2 to the second power plus 2. Okay. So the power is already done. I don't have to add or subtract anything. So the power is already just the power. So let's go to, so we have 5 times 5 times parentheses 1 divided by 2 power. The first power is -2. And then I have a -2 at the end. A -2 at the end. Or was it a +2? No, it was a +2. Okay. 22. So my first dot is going to be left 2, up 22. That's just off my graph, right? So let's go to the next one. We'll worry about that one later. Let's go to my next one. Next one is -1. So now let's go change the power to -1. 12. That one's on my graph. Next one, 0. Change the power to 0. 7. Okay. Change the power to +1. 4.5. Change the power to 2. 3.25. 3.25. So that -2 was just off my graph, right? If I go left 2, up 22, it's just off my graph. So instead of the top guy, instead of this guy here, what number should I plug in here that would give me a number thing, something on the graph? 3. So let's do 3 then. Three. Since I already have it ready, it's just easy as changing this number here. 2.625. So 2.6. Now I got my 5 dots. Okay, so the first one, -1 up, -1, left 1, up 12. 0, 7. There's not a 7 on there, but it's between 6 and 8. 1, 4.5. Right 1, up 4.5. Between 4 and 5. 2, 3.25. So 2 barely above 3. And then the last one was 3, 2.6. So it doesn't ask me growth or decay because you can see it's decay. It matches the decay picture. It does ask me where the bottom is. Where is the bottom going to be for this guy? Yeah. This 2 right here means that that's going to be the bottom, right? If it's got something out there, a plus or a minus, that's going to be it. So it's going to be y equals 2, positive 2. The bottom of this graph is going to be right there. Domain is always the same. Range goes bottom to top, right? Bottom to top. So we said the bottom was 2, and then it goes to positive infinity. There you go. Okay. So that's what I want you to do for the other 5. The on Google Classroom, the key is posted. It's not here, but it's the key is posted. It doesn't give you the table, but it gives you the picture. You know what the picture is going to look like, right? You know what the picture. It's either going to look like this guy on the board or this guy on the board. All the pictures are going to look like that. So if you have a dot that doesn't match that pattern, you probably did something wrong on the calculations. It's an easy way to check. Okay. Most all of these curves are all exponential. So they're either going to be growth or they're going to be decay. Okay. That's an easy way to check them.